Hello, I am Dr. Deepthi and we are looking at different topics from maths under the heading Decreations Mathematics. We have been looking at the broad topic of linear algebra, and in that the focus has been on matrices. We have learned about several basic concepts related to matrices. We began by understanding what exactly matrices are, looked at their real life applications, then learned what is matrix algebra such as addition, subtraction, scalar multiplication, etc. We also looked at matrix multiplication and checked whether it is commutative, and then we wanted to tackle the concept of inverse. Now, if you want to find out inverse of a matrix, there are certain prerequisites that you should know very well. So, when we were trying to find out inverse of a 2 by 2 matrix, we learned about determinant because that is the only concept that is necessary there directly out of the concepts given here. But now that you want to go for 3 by 3 matrix, you need to be well versed with all the concepts such as determinant, minor, cofactor, adjoint or adjuvate. Since past I think 3 to 4 episodes, we have set this as a goal, finding out inverse of 3 by 3 matrix, and today we are in the last step to accomplish it. But as I said, check whether you are well versed with all these concepts and even the basics which I mentioned earlier in the episode. If you are not, then please visit the previous episodes, practice it, of course, after understanding the concepts. And then when you feel confident that now you are very well versed with all these concepts, then you can start with this video. Those of you who are already well versed with it, great, you can continue with this video. But make sure that you know all these things very well, because as you can see here, formula for inverse of 3 by 3 matrix is A inverse is equal to 1 upon determinant of A into adjoint of A. Or if I have to rephrase it, adjoint of A upon determinant of A. So unless and until you are comfortable with finding out adjoint and determinant, there's no point in proceeding further, right? So check for yourself, and then when you're confident, you can begin with this. So what is a typical route that needs to be followed? Well, first step is checking singularity of the matrix, because as you can see, it is here in the denominator. So you need to find out the determinant. If it is 0, that means if the matrix is singular, you cannot obtain inverse for that matrix. The journey ends there. But if the matrix is non-singular, you can find the inverse for that matrix using this particular formula. Now, we have already calculated the determinant, so we are comfortable with the denominator. What about the numerator? Adjoint. Now, if you recall, in order to calculate adjoint, you need to calculate minor and hence cofactor for each of the elements in the matrix. Then you have to organize it into a cofactor matrix. Take a transpose of this cofactor matrix to get the adjoint. And then finally substitute the adjoint here, determinant in the denominator, and you get the inverse of the matrix. Now let us solve an example so that you see you don't have to mug up this particular route. Just look at the example, understand what we are doing, and this will be very easy. Alright. So let us take example of matrix A. This is the given matrix. 9, 2, 1, 5, minus 1, 6, 4, 0, minus 2 are the elements. As you can see, it's a 3 by 3 matrix. 3 rows and 3 columns. So what was the first step that you need to do? You need to check the determinant. So let's do it. Let's try to find out determinant of this matrix. Recall the concept. So take the first row, first element, first column, first row. So it is 9. And then minus 1 into minus 2, minus 6 into 0. You can see it here. Minus this term, 2 into 5 into minus 2, minus 4 into 6. You can see it here. Plus this term, 1 into 5 into 0, minus 4 into minus 1. So if you simplify it, it is going to become 9 into, this product is of course plus 2, this product is 0, minus 2 into, this product is minus 10, this product is minus 24, plus 1 into, this product is 0, plus 4. If you simplify it further, 2 minus 0 will give you 2, minus 10 minus 24 will give you minus 34, and 4 plus 0 will give you 4. So it becomes 18 plus 68 plus 4, that gives you 90. So we are done with the first step. We have found the determinant. We can see that it is non-zero, that means the matrix is non-singular, and hence we can find its inverse. So obviously, since we know the denominator now, we need to concentrate on the numerator. Let us find out the adjoint. Now in order to find the adjoint, we need to find out cofactor. That means we need to find out minor. If you recall, while finding out the minor for any element, say A11, you have to ignore all the elements in that particular row and column, and then take determinant of the remaining elements. And then how do you give a sign to that? It's minus 1 raised to I plus j, where I is the number for the row and j is the number for the column. So in this case, number for the row is 1, number for the column is 1. So 1 plus 1 is 2. Minus 1 raised to 2 gives you plus 1. So sign doesn't change. Now, it's very clear that if the addition of I and j is going to be odd, the sign is going to be negative. So just like for A1, 2, A2, 3, A2, 1, A3, 2. So can you see it here? It's like a chessboard, the way you have black and white squares. So the signs are going to be alternate in this manner. So what we'll do is we will try to evaluate cofactor of element A11 for this particular matrix, and rest of the things you need to evaluate on your own. Okay. So if I want to evaluate cofactor for element A11 of this particular matrix, 9 is the element, and then since it's A11, ignore all the other elements in first row and all the other elements in first column. So you're left with minus 1, 6, 0, minus 2. This is minus 2 into minus 1 gives you plus 2, and this term anyway is 0. So the answer is plus 2. And we know if it is A11, that means minus 1 raised to 1 plus 1. So you know the sign has to be plus. That means the sign is retained. So you get cofactor element to be plus 2. Right? Now your task is to find out cofactor for each of these elements, each of the remaining 8 elements of the matrix. So I would suggest that you pause this video here, calculate the cofactors for each elements, and once you are done with that and attach the signs, of course, then write the cofactor matrix and only then resume the video. Because I want you to be involved in this process. It shouldn't be a one-way process that you are just watching something, that's all. See, you have to be there. If you are given any matrix, you should be able to calculate it. If you are able to do that, only then it's of use. If you just read it right now for the sake of it, or just watch it, that's all. And if you forget about it, then there's no point. So I would say that pause the video right now, and only after you formulate the cofactor matrix, you can resume the video and start watching. Okay? Alright, so I presume that you have now calculated all the cofactors for the elements and written the cofactor matrix. So now your job is just to tally. So this is the cofactor matrix, 3 by 3 matrix as expected. These are the elements: 234, 4, 4 minus 22, 8, 13 minus 49 minus 19. So what is our next task? We just have to take its transpose. That means exchange of rows and columns. So this is the adjoint of the matrix. 2, 4, 13, 34 minus 22 minus 49, 4, 8 minus 19. So now if you look at or take a recap of what we did so far, we first found out determinant. It was non-zero. It turned out to be 90. And hence we knew the matrix is non-singular, hence invertible, and we proceeded further. We calculated adjoint. So now we know adjoint, we know determinant. So what is left with us is just to substitute. And when you substitute, this is the inverse of the matrix. 1 by 90 into adjoint matrix. Now the task ends here, but for your sake, what I am going to do is I am just going to ask you to verify. So we know that if A inverse is the inverse for the matrix A, product of A into A inverse should be an identity matrix. And here, since we are dealing with order 3 matrices, it should be identity matrix of order 3. So I want you to take product of these two, and we have already learned matrix multiplication in the previous episode. So quickly take the product. You can pause the video till you are doing that. Once you are done with it, you can cross check that it comes out to be the identity matrix. So what is the takeaway of this video? Basically, this is the formula. A inverse is adjoint of A divided by determinant of A. The route that one needs to follow is checking the singularity. That means checking the determinant. If the determinant is non-zero, that means if the matrix is non-singular, we can find out the inverse by computing minor cofactor, formulating a cofactor matrix, taking its transpose to get the adjoint, and the final step is computing the inverse. And this kind of a question, as I said, you yourself can verify whether you've got the correct answer, just the way we did a while ago. Simply take product of A and its inverse, and if it comes out to be the identity matrix, you've got the correct answer. Alright, so we'll stop here and then meet in the next episode with some more interesting topics from maths.